Hey folks, I'm Kevin Baichoo. I'm a Envoy maintainer and I work at Netflix. And this talk is about how we use Envoy at Netflix. So to an overview of the talk, I'll motivate why we chose Envoy, why we needed it, how we adopted Envoy, and some of our learnings from using Envoy. So uh, Netflix has a variety of clients, TV, phones, etc. They hit an edge gateway, and that forwards requests to a bunch of microservices. So this is a pretty standard industry problem. You have a polyglot environment. You want uniform capabilities. So the solution is to use Envoy-based sidecar. Um, we have these sidecars running on VMs, containers, and laptops. Thankfully, the talk won't be about debugging people's laptops. For egress adoption, the kind of two unique pieces here that I think we had was on-demand CDS or ODCDS, and the ability to incrementally adopt Envoy for a variety of services. So, as standard in the industry, when instances come up, they register themselves in a service registry. Now, when the application wants to talk to a particular service, it sends Envoy a particular header, which Envoy uses in ODCDS to resolve the Envoy cluster config. That then responds with the config, and then Envoy is able to call the service as expected. The incremental adoptability part comes in with the fact that the client can skip going through Envoy and actually talk to the service itself. This was useful when we didn't have particular knobs or capabilities that would block adoption of Envoy for this particular app. For ingress adoption, the unique piece here is kind of hot restarting the Envoy when the app programs Envoy. So in effect, the applications start up and they typically will egress through the Envoy and fetch some runtime config. This runtime config might then change how they want the ingress Envoy to behave, and in that way they can program the Envoy, the ingress Envoy, and reload it through a hot restart and finally register for service registration. So moving on to some of our learnings on what we've learned through adopting Envoy. We had too few connections. So this is connections between the app and the egress Envoy itself. The problem here is we were using one connection exclusively for a target service. This meant the RPS to a given target service was bound by the RPS of a single Envoy worker. Sometimes that wasn't sufficient for high RPS use cases. So the solution here is to use more than one connection per target service, or to multiplex services on connections. Or so with this, right, you'd think your RPS is now bound by the number of Envoy workers, right? Or so you think. Again, this is between the application and the egress Envoy, the connections there. You can apply the exact connection balancer that Envoy has, and you will balance the connection, but you won't actually balance the load. And those are two very different things. This graph here on the right is in effect kind of egress RPS per worker. And you can see that it's spread all over the place, right? And there's the black line and the pink line at the top. The worker there is doing about 1K RPS, and the purple and brown line at the bottom, the workers are doing 100 RPS. So this is significant imbalance. The solution here, or one solution here, is to use more connections to in effect have kind of fine-grained balance of the load. We then ran into problems with having too many connections, this time in the Envoy itself, egressing. This is because Envoy has a problem with high fan-out. So if you look at the diagram at the bottom left, we have mcaller instances and n target instances. And if you have C workers in the callers, you end up with m times n times C connections. It's a lot of connections, and it can risk ooming across a fleet. The solution that we applied here is to apply connection subsetting. In effect, just informing the caller envoys of a subset of the callee instances. This significantly reduces ooms and connections that the fleet has itself. So this is a graph here demonstrating us rolling out subsetting to the fleet. The blue line, in effect, shows that we have about the same number of instances, and the brown line, is the number of connections that we have. And you can see that we go from about 100 million connections to about 50 million connections after rolling out subsetting. We then had problems with not having enough connections. This time between the ingress envoy and the application itself. In particular, this was a problem during a traffic spike scenario. So this graph at the top left is a graph of RPS, and it's in a load testing setup where the green part is in effect a warm-up phase, and the red part is the part where we're actually traffic spiking. You see the spiky line, right? Now, by default, at a minimum, Envoy will have num worker connections between the ingress Envoy and the application itself. And the problem that you encounter with this is Envoy will lazily open the ingress connections per worker, leading to queuing of requests. And you can see that in that top right graph there. That's basically pending requests in Envoy. And you can see it sharply spikes up because it's having a traffic spike, but it doesn't yet have enough connections to actually handle the load. This queuing can tip over the app/success ratio of your requests. The solution here was to bump up the connection pool cardinality to, in effect, have min num workers times cardinality connections to avoid queuing, so you could better handle those spikes of load. So beforehand, in the graph on the left, you can see the number of ingress connections between the ingress envoy and the app. And you can see, it has a few vertical points. Those are points where we're queuing, waiting to create new connections before we can then send those requests off to be handled. Afterwards, right, we just end up having 80 connections already warmed to handle all the load. There are a lot of talk today about the filter chains and them being independent of each other. So we have request 1 here and request 2 here, and they have their own separate filter chain, right? But if you're using WASM, the WASM VM is a shared resource across these filters. So what happens when your WASM VM crashes? Well, everything is impacted that uses it, right? So you end up getting black holed, right? A solution here, if you're using WASM filters, make sure you configure your VMs to be restartable. Huffman encoding. It makes a lot of sense in some scenarios, especially remote scenarios, but it doesn't really make a lot of sense through local connections, right? It's a waste of CPU. And solution here, just remove Huffman encoding. We saw real-world savings of 5 to 10 percentage points in CPU. Envoy's stat system. The stat system is incredible. It's a real beast, and it has a lot of, without it, Envoy would just use a ton of memory because Envoy generates a lot of stats and it has a lot of observability. But in order for the stat name system to work, it does a lot of compaction. And you really need to handle it with care when you're using it. So the problem here is we were excessively stringifying the Envoy native stat names, which led to in effect lock contention. So the off CPU flame graph to the left in effect shows that lock contention. All those red boxes are points where we're basically blocking because we're taking locks to stringify stat names. The solution here is to avoid stringifying, use the Envoy native stat names with care. On demand, it's great if you could keep up, but what happens when you have a slow control plane, right? In effect, with ODCDS, it can end up leading to request failures. This is because with envoys that don't yet have the cluster, right, they can't actually serve traffic. We saw this in production. So this here is a graph. The points highlighted are showing CDS and RDS latencies, and those are in hundreds of seconds. So, it can get pretty bad. Um, Likewise, we had LDS timeouts. That's the green line there. And the problem with LDS timeouts is, in effect, you're going to have some config-less proxies, aka a brick, which isn't very useful. This is a tough one. Get/build a good XDS server. Um, Thank you, and I hope you learned something today. Come find me at the maintainers booth, and we're hiring. Find my manager, Anjali Kanak, in the crowd.